We have vacuum pumps on the top. So at least you guys can hear me.
Holy
so what's
crap.
on the inside of this thing, the rings you see, are 3,000 permanent magnets bolted to the inside wall of this sphere. And what those magnets do is they stop the plasma from touching the wall. Well, basically the magnetic field turns it away. A plasma particle comes towards the wall, and the magnetic field curves it. Yeah, it hovers in the middle, and it's really neat. Yeah, it would be nice to have it on right now. I'm sorry it's not on, but plasma. Yeah, we have plasma inside.
What's with
you guys know what plasma is, right?
What did you tell me?
Video.
Exactly. Right?
It's magnetic.
So that means
Yes.
we fill it with helium, let's say. We fill the inside with helium gas. Because it's bolted to the ground. Yeah. And so we make the plasma by discharging electricity between two electrodes that we stick in. So it's kind of like a lightning bolt. Lightning bolts make plasma, that's why they light up. And what we do is we make plasma and it stays plasma because of the magnets on the wall. It doesn't hit the wall and cool down. So the question we're trying to answer with this is, why do planets like the Earth and stars like the Sun have magnetic fields? Now, do you guys have any idea why the Earth has a magnetic field?
Because it's gravity.
So, yeah.
I dare you to jump.
Absolutely. Everyone hear that? It's because the Earth's core is liquid metal.
That's scary.
And it's spinning with the Earth's rotation. So the theory is a liquid that conducts electricity and is spinning can generate a magnetic field. And this works in the Earth because the core is liquid metal. It also works in the Sun because the Sun is plasma. And plasma, like liquid metal, conducts electricity. So in this experiment, we're going to try to make plasma in the middle and then spin it,
that scared
just
me.
like the Sun spins. And we're going to try to measure a growing magnetic field. So we're trying to confirm the theory via experiment. Right now, we are still in the stage of making plasma. We haven't started measuring growing magnetic field yet. But basically, there are steps to this experiment. First, we have to make the plasma and get good at making it, and good at knowing how hot it is, how dense it is.
No.
And then we need to try to spin it.
It's a video.
Sorry.
So.
Exactly. We have to get the basics down first. And so a year ago, none of this was here. This is a totally empty room. So in the past year, we installed this. You guys saw the video. We had to tear down the doors, actually, because these are too big to fit through the doors. So those are new doors. We had to build them again after we got these in. So we installed this. It used to look like the Death Star. No, stay up here. There's a lot of electricity and power stuff downstairs.
Yeah, power stuff.
Even though it's not on. Before we put the foam on, this used to look like the Death Star, so we used to call it Death Star. But then we put this foam on, so we put the foam on to insulate the machine.
And it looks more fun.
And it's custom ready.
About how much would this thing weigh if nothing were holding it up?
That's a very good question. It's probably, I would say, a couple tons. It's all
Wow.
aluminum. It was cast. It's cast by like a company that makes truck beds down an hour north of Madison. And it's actually a really good vacuum chamber. People were kind of skeptical that it would work, but it works really well. The foams for insulation. You see all these little pipes coming out of here?
Yeah.
The plan is to hook waterproofing up to all these pipes. Because when we make plasma, the plasma is very hot, and the machine heats up. And so we want to keep the machine cool, because if the magnets get too hot, they lose their magnetization. And that would be like $500,000 down the drain. So that's what the installation is. I have a question for you guys. Oh, no, go ahead.
What is the plasma look like?
It depends on the type of gas. If it's argon, it's really bright purple. And you actually have to wear special goggles because it emits lots of UV. And so it's like
Ultraviolet? Wait, ultraviolet rays?
Absolutely, yeah.
Woo.
If it's helium, it's a kind of a pinker plasma. If it's hydrogen, it's a redder plasma. It all depends on what gas you're using. And also, how hot it is. All right, so I have a question for you guys. How hot do you think the plasma in here gets?
Hotter than the surface of the sun. I don't know.
20 million Kelvin.
Holy
That's
crap!
too hot. That is as hot as the
That's
center
like
of the sun. And
evaporating water in a millisecond.
20,000 Kelvin. That's closer. That's probably about right. 20,000 Kelvin is about right. So this is a cooler experiment than, say, MST. MST is trying to solve the problem of fusion, which takes place in the middle of the sun.